All right, so today we have Zongheng Yang. He is a researcher in the Sky Computing Lab at UC Berkeley, and we're going to talk about one of the key projects there that he leads called SkyPilot. So Zongheng, welcome to the Data Exchange Podcast.
Happy to be here. Thanks for having me.
All right, so I think for our listeners, just to lay the groundwork, so everything we talk about and everything and most of the effort that you're putting is towards realizing this vision that you folks at Berkeley have labeled sky computing. So what is sky computing?
Yeah, so sky computing is this vision proposed by Jan Stoika and Scott Schenker, who two professors at Berkeley. In one sentence, it is the next evolution of cloud computing in our vision, and we basically want to break the current landscape of cloud computing, where you have locking, very significant locking due to volume contracts, data gravity, and so forth. We want to break this, and we want to make it easy for users to choose the best cloud for their workloads, right? We want to make it easy to move workloads across clouds. And one analogy we've been giving is we want to enable this internet of clouds, and that is sky computing.
So is this, Zongheng, is this related to this notion of, people have this kind of visual that they use, the infinite laptop? So in other words, you're on your laptop and you basically have infinite resources, but for all intents and purposes, you feel like you're on your laptop. So what are some of the, in other words, I guess what I'm asking is, what are some of the characteristics for the end user when sky computing becomes a reality?
Right. So we believe there are a few key benefits that this will bring on top of the existing cloud computing landscape. So for example, one trend we have been seeing is there are more and more specialized hardware or services being offered by different clouds, right? For example, on Google, you have TPUs, which are very good for training, and other clouds may have their customized hardware for training. On AWS, you may have an inferential chip, which is very good for inference workloads. And on Azure, you may have secure computing hardware, right? Intel XGX and so forth. So even though within one cloud, you may already have an illusion of infinite laptops, right? Because that single cloud can offer a lot of resources for the end users. But we really see that, this trend of specialized hardware and specialized services being offered by different parties to continue. So this gives you a very strong incentive to use the appropriate cloud for your particular applications, right? So that's one key benefit. And then there are a lot of business reasons to use multiple clouds, right? Avoiding locking, enhancing your negotiation leverage, and being more robust against failures.
So basically, then you can use the best of breed, and it will be very, very kind of frictionless.
That's right. That's the vision we are working towards. We want to make it very easy to use best of breed hardware and software, as well as best-in-class pricing, because the pricing for the similar hardware or the same hardware can differ quite significantly across clouds.
And I know, so this is kind of a grand vision, but you folks are rooted in reality. So you've kind of confined yourself, at least for now, to the machine learning space, right?
That's correct. That's correct. We started building SkyPilot, which we will talk more about. This system is currently geared toward machine learning training workloads and other batch computations.
All right. So which brings me to SkyPilot. And so let me read you the, I don't know where I got this, might be GitHub, might be the docs. So SkyPilot is a framework for easily running machine learning workloads on any cloud through a unified interface. Okay, so then before we get into the internals of what it is, so what is the end user experience and benefit of SkyPilot first? Okay, so if I'm an end user, what's different if I start using SkyPilot?
Yes, yes. So the key challenge it will address for you, SkyPilot addresses for you, is running ML on the cloud today is just too complex and too expensive for the average user and average team, right? And I can give you a few concrete.
So wait. So let me. So the listener will say, well, aren't there things like SageMaker and equivalent services on Azure and Google? So if I'm completely convinced that Amazon managed services are the way to go, isn't this easy?
So I think that's a very good question. I think managed services like SageMaker, they solve a lot of problems. But I think fundamentally it's still about flexibility. They require you to use their cloud, right? And oftentimes, for example, SageMaker, when you want to start using it in a program, you specify your region first, and then your job is tied to that region, right? There's no regional flexibility, and we will talk more about why this will become more and more important, regional flexibility. And then there's a matter of API flexibility, right? I think SageMaker is great if your models fit into their prepackaged patterns or classes, right? They have some estimators and things like that. If your models fit into that, it's great. It's very easy to use. But when you start using more complicated stuff, or if you are a researcher, you want to build new patterns, right? Then it may not fit your use cases. So it's great for a lot of use cases, no doubt about it. But I think it's about flexibility in terms of API, in terms of region, and not to mention pricing, right? Pricing, they charge an additional on top of the underlying compute.
So the end user experience, so an end user on a laptop, and I know the answer to this, but because I went to your talk at the recent retreat, but for the sake of our listeners, right? So for an end user, so if I'm on my laptop, I'm going to do machine learning. First thing I'm going to do, pip install all the libraries I need, and then I write the program. I get my data, and then I do whatever it is I'm going to do. Data processing first, and then training, and so on and so forth. But I've got a kind of a very well-defined process if I'm operating, let's say, in the Python world, right?
That's right.
So how complicated will it get if I start using SkyPilot?
It will be very easy. You can bring any framework, right? Your program can be written in any framework. We are not a programming framework that you have to fit your programming. You can use PyTorch, TensorFlow, MXNet, and so forth. What you need to do is just to define, hey, here's my job. Here's my code, the working directory, my data, like you mentioned, and you additionally say, I need certain amount of resources, right? I need 4 V100 GPUs, or I need 32 CPUs.
What about the libraries and the dependencies among the libraries?
Yes, and then you have a way to say, here's my dependencies. Please set it up like this. Pip installing some requirements file, or conda installing some environment file, right? And then finally you say, here's my main program. Please invoke it. So you have a very easy way, intuitive way, I should say, to package your existing project. And you throw that into SkyPilot, and SkyPilot will run it on the cloud and handle a lot of heavy lifting for you.
So if I decide, so I don't know if this is possible. So if I decide, okay, so for the data processing step, it looks like I can use some things in Google. I'd like to use Google for the data processing step. For the training step, there's certain hardware on Amazon I want to take advantage of. Is this possible right now with SkyPilot?
Yes, it is possible. We have built this support for, you can bring a pipeline of several stages, right? Like you said, data processing and training, and maybe inference at the end. But what we've been seeing from our existing users, a lot of them are just using a single stage, right? Here's my training job, or here's a bunch of training jobs. Please run them for me. And even for that, this single stage, single jobs use case, I think we are providing a lot of benefits in terms of handling the cloud infra complexity, cost, and productivity.
So you talked about the importance of being able to do things across regions. So explain.
Yeah. So this is actually, I think it's very seldomly talked about aspect. Why we need to use multiple regions. I think this will come down to a few factors. One is different regions have different services and different hardware they require, right? For example, you go to AWS, you say, I want this GPU instance. It may not be offered in all the regions, right? It may just be offered in particular regions. So that's one thing. The other thing is these regions can differ a lot in their pricing for the same instance type. Maybe most users, they are accustomed to, I just go to my default region. But what we found is that oftentimes it's very beneficial to shop across regions, especially for things like spot instances. Spot instances can even differ in pricing across zones within one region. So I think these two are in terms of pricing and what resources are offered. But I think the third one is also very important, which is resource availability, right? You go to one region and you say, I want this instance type. AWS may tell you that I run out of capacity. I cannot allocate this machine for you. Then what do? Then, what we see from our users and our own experiences is just you either wait, you retry in that region after a certain amount of time. And this waiting time can be quite long. It can be tens of hours or even up to 1 day for, the popular GPU, high-end GPUs. Or you can manually retry in different regions. And that is just a, painful and trial and error process. So I think really you want an automated system to automatically leverage multiple regions for all of these reasons.
So essentially what you're saying is if I use SkyPilot, I can stop thinking about regions.
Absolutely, yes. So we really just provide a high level interface for you. You say at a high level, I want these GPUs, this amount of GPUs, or you can say I want this amount of CPUs, right? And you don't need to say I want to allocate in this particular region or this particular cloud. We will do that automatic shopping for you. But on the other hand, we also expose this kind of control for the advanced user. If you really want to say, hey, my job really has to run on this particular region, you can say that.
Yeah, for whatever regulatory reason, right? Like,
that's right.
Maybe you need to be in Europe for some reason, right?
That's right. And another interesting case we see for this regional flexibility is nowadays many teams are distributed across the world, right? Maybe you are in Hong Kong. And then in this case, it does not make sense for you if you're doing interactive development. It does not make sense for you to connect to US East, right? The latency will be pretty significant. And in using SkyPilot, it's very easy to just change one config to say, I want a machine in Asia Pacific, then the latency will be cut down significantly.
Interesting. So when you say, so in many ways, you remove kind of all of these manual selection and decision-making for me, the end user, in terms of regions and clouds. So, but as you do that for me, what kind of optimization are you doing? So in other words, is it just basically you just go through a list? Okay, so, or do you actually optimize for cost, performance? So what kind of knobs can I turn in terms of to instruct SkyPilot? Okay, I want you to do all of this for me automatically, but this is really what I'm most concerned about.
Right. So let me back up a little bit to give a 2-sentence summary of what SkyPilot is. So SkyPilot is an open source framework we are developing at UC Berkeley for running machine learning and batch jobs on any cloud, right? And it removes the cloud infra complexity and it saves costs for the users. And in simple English, basically it's a framework that allows you to say, here's my job, here's my requirements, and we will figure out the cheapest region, zone, and cloud to run this job. And we will
So automatically cost is optimized.
That's right. Currently, we default to automatically optimize for cost, and we do it. Currently, we do it in a simple manner. We compare for your resource requirements. We compare many choices in the search space. This search space can be all clouds that you have enabled. If you are a single cloud user, then it's all the regions you have enabled, right? But if you are a multi-cloud user, then this search space will be enlarged. You will have multiple clouds regions. So we go ahead and look at all these choices, and we just go through them in a cheapest price order. Now, I should say that we do have experimental effort in making this much more sophisticated, right? Not just cost. Maybe you want to optimize for time, right? Or maybe you have a deadline, but subject to the deadline, you want to minimize the cost.
Yeah. Maybe I'm not an expert in terms of hardware. And so, but I want you to be able to, I want you to choose for me hardware so that my job will finish in 6 hours instead of 12.
That's right. That's right. So I think these are non-trivial problems. There are work being done behind the scenes. We are doing a lot of research on SkyPilot and this new setting of Sky computing. Right now, in the system, we do something pretty simple.
So by the way, so when it comes to hardware, so there's the flops for the chip, but then what about memory and memory bandwidth and all of that for someone who doesn't know all the latest and greatest in hardware? So how do you kind of make these choices automatically for people?
Yeah, that's a really great question. I think even higher level than that, you were talking about flops and memory bandwidth, like even higher level than that. I think even the basic CPU instance family is already very confusing. There's a overlap.
Yeah, the drop down menu is long, right?
Exactly. I don't know how many instance types each cloud has, maybe hundreds to almost 1,000, right? Like we want to provide the ability for people to say, I just want 32 CPUs. Just give me some same default, right? So maybe here one sensible default is we go to the latest generation general purpose CPU family, right? If you want 32 CPUs. Additionally, you may want to say, hey, I want Intel or I want AMD, right? That's about it. We don't want people to be buried under this information, right?
Too many choices, right?
Exactly. Too many choices is a big problem.
So you've used two phrases that I want to drill down a little bit. The first one is data gravity.
Yeah.
Which anyone listening to this episode, the first thing their reaction will be everything that these guys are talking about are impossible because I have my data already in one region in one cloud. So talk about data gravity first.
Yeah. So data gravity is a top of mind concern for a lot of teams, right? Like you said, my data sets have been accumulating in one particular region. Why should I go to different regions? So I think the answer to this is manifold. One, I think even if you are just using one region, I can talk about why, but using SkyPilot inside one region is also highly beneficial, right? It's not about moving across regions anymore, right? It's about some other complexity being removed for you. So this is one thing we want to emphasize more going forward. Even if you use one region, SkyPilot handles a lot of complexity. For example, like spot instances, all that stuff. Now, if you are really thinking about, okay, I have a lot of data sets in one region, and you're telling me maybe there are reasons to go to different region. What do I do?
Yeah. For example, like you mentioned earlier, now I just realized, hey, for this problem, I need TPUs.
Yes. Yeah. So there are many trends happening in the industry that we think will mitigate this problem. One trend is, the Data Alliance from Cloudflare, and this is a collection of cloud providers partnering together, right, to eliminate or significantly lower the data transfer cost among them, right? So nowadays, moving data out of one region to a different region or out of one cloud to a different cloud is very expensive, right? And within one cloud is slightly less expensive than out of one cloud, but it's still expensive. So Data Alliance is a way for these clouds to band together to try to mitigate this problem. And we are very excited to see this happening. This will make it easy to move your data set, right, in terms of cost. The other thing I want to say here is data gravity is a big problem for big data sets, right? If we are talking about like petabytes of data, or everyone has a different definition of big, but if you look at machine learning, many data sets are in a reasonable scale in terms of size, right? Let's say if you're a company doing a computer vision, maybe ImageNet is a reasonable ballpark. ImageNet is only 145 gigabytes or so, right? And we have also been working with users doing computer vision models on their own data sets, which are about 10 terabytes on that scale. And on this scale, I think moving that data set to a different region costs about a few $100s. You may do it once and enjoy the benefits thereafter.
And this is in general without invoking. So for our listeners, there's another Skylab project called Skyplane. So even without Skyplane, these are reasonable costs?
Yes, that's right. Skyplane is a very cool research project and open source project from our group as well. What it does is it makes moving data sets across cloud, or even within one cloud, but across regions, very cheap and very fast. And it plays a lot of tricks to enable that. But this is the third trend that I want to mention. We believe these kind of tools or systems to combat data gravity will pop up more and more in the future, right? So Skyplane is one example to make it much easier and much cheaper, much faster to move data sets.
So the other word you used earlier was batch.
Yes.
So it seems like right now SkyPilot is optimized for batch training and batch inference.
That is correct. Our focus has been batch computations and machine learning training on GPUs, TPUs. Batch inference is pretty similar. We also do scientific batch jobs based on CPU. So these are non-GPUs, non-machine learning jobs from researchers in natural sciences. So these batch computations are very amenable to this approach because they are relatively easy, relatively self-contained, I should say, right? They don't depend on 10 microservices to function. So if you are talking about some infrastructure or some application that depends on many microservices, then moving them across regions or clouds can be much more complicated.
What about online learning and online inference?
Yeah, so I think online learning and online inference, we are very interested in exploring, especially online inference. Most people, most teams, they don't want to train their own model. They maybe download some pre-trained models and they fine-tune on their own data, and then they serve their customers, right? Serve this model. We are very excited about exploring this use case for several reasons. One, if you are talking about online serving, you want to minimize costs, right? Perhaps you want to use a pool of spot instances, right? And SkyPilot has a managed spot component where we automatically offer you the ability to recover from preemptions without your intervention, right? So you just launch your jobs and computations, maybe they are online inference servers, and we will make sure to automatically recover them if they are preempted. So that's one reason we believe this will be very beneficial for this workload. The other reason is I think SkyPilot right now is adding more and more clouds. We just finished integrating with Lambda Cloud from Lambda Labs. As you know, Lambda Labs is a leading low-cost GPU cloud provider. So these guys have very competitive pricing. They are like 3 to 4 times cheaper than the big three cloud providers. And if you want to save costs for your online inference, then doing it on such low-cost GPU cloud is a natural choice, right? So we believe SkyPilot supporting these low-cost GPU clouds can also be a reason why you want to do online inference here. And third, I think online inference also has to do with regions, right? You want to be close to your requests, where your customers are. And because of the regional flexibility we offer, I think that's also a natural fit. But these are just currently planned. We are not doing it yet, but we are very excited exploring this use case.
So I recently looked at what are people talking about or thinking about in terms of data science tools, right? So, and one of the things that popped out is kind of the use of serverless technologies for data science. So, does SkyPilot have some benefits when it comes to serverless settings?
Yeah, so I guess when you mention serverless, usually people can mean two things, right? One is you are really talking about AWS Lambda style functions, right? Or you are talking about serverless style API in the sense that you don't think about clusters, you don't think about servers, right? You just present serverless APIs, you think about jobs, right? Here's my job, I don't care how you manage it, just run it.
Which is basically what SkyPilot sounds like, right?
SkyPilot offers both serverful APIs and serverless APIs, job APIs, I should say. Many people love the serverful APIs for interactive development, right? This is not surprising because they value the ability to log in into the same server, right, to do that development. And at the end of the workday, they may have it automatically stop. And second day morning, they restart it, right, to have all their data in one place. So I think a lot of people value the serverful APIs. And for the job APIs, we really offer it through the managed spot library. Managed spot is basically you say, I have a job to run and please run it on spot instances and please recover it for me if preemptions happen. So a lot of people are using that as well. So this is more in the production stage of a project.
So SkyPilot is evolving in the kind of the same tradition as the typical Berkeley Ion Stoica open source projects like Spark and Ray and things like that, in the sense that it now is also being used by real world practitioners, right? So it's no longer just an R&D in the hands of researchers. So describe some of the most interesting use cases for our listeners.
Yeah. So it's been super positive. As you know, we only publicly announced the project 2 months ago in November, and we've been gotten a lot of interest. So some major use cases I can mention include machine learning training on GPUs and TPUs. Actually, TPUs are a big use case for us because everyone should check them out. Google offers this TPU research cloud program for researchers, and they give you free TPUs basically, but they only give you the hardware, the instance. How do you manage them, right? So a lot of people are using SkyPilot to launch their large model training on these.
So these are deep learning models.
These are deep learning models, very compute intensive, yes. And one industry use case I can mention is an AI company has been working with us to productionize using SkyPilot inside their company. So this has become the way they do machine learning on the cloud. And so these guys before SkyPilot, they were using local on-premise cluster. And as you know, that has many problems, right? One problem is reliability. A machine can suddenly go down, without any warning. You suddenly cannot SSH into that machine. Or, suddenly while your training job is running, the NFS becomes super slow, right? Suddenly there's some disk or network IO bottlenecks. In such cases, this required them to call up the operators to say, hey, go troubleshoot this machine for me. This is a big problem, right? Because it stalls the progress of machine learning model development and training. It wastes the invaluable, I should say, human time. Another problem with on-premise cluster they were having was they are doing spreadsheet scheduling or Slack scheduling, right? It's like saying, hey, Bob, you get this machine, or Alice, you get these two machines, right? It's very statically partitioned among the ML team. And this is very rigid. This means they cannot scale. If I want to do a model training run on 16 machines, it's very hard for them to do because of this static partitioning. So with SkyPilot, they were able to move all of their model training code to the cloud with minimal code changes, right? The job definition, the packaging that we described, they use that to wrap their existing code with minimal changes, and they were able to run all of their models on the cloud within 1 month. So this is one big benefit they get. And we talked about elasticity, right? Now they moved to the cloud. They were able to scale as much as they want, right? They were able to cut model training time from 2 months to 2 weeks, just because now you are in the cloud, you can use much more machines. So this has been super positive for them. And finally, I should mention, like we've been mentioning, one major way of saving costs is spot instances. So they are using SkyPilot to run training exclusively on spot instances, saving them more than 3x, I think, compared to on-demand instances. Now, you can say, okay, what about compared to the previous solution, on-premise cluster? In this case, using spot instances on the cloud is comparable or even cheaper than on-premise cluster. And as a result, I think they are trying to reduce their on-premise cluster size by half.
So you alluded to earlier that SkyPilot is great for basically batch computation. Primarily right now, most people are using it for training and inference of machine learning. But outside of machine learning, have you noticed any other use cases for SkyPilot?
Yeah. Another big use case is this scientific batch jobs from Salk Institute of Biological Studies down in San Diego. So the Joe Ecker group inside Salk Institute have been working with us for about half a year or so. They've been using SkyPilot to do their genomic applications, genomic computations. So these are very heavy, CPU heavy computations, right? Oftentimes they require the largest CPU instance on that cloud, right? So think 100 CPU per instance. And these computations are also recurring, right? Based on weekly incoming data, they need to launch the same computation on the new data. So these are also weekly recurring. And finally, I should say, these are also batch computations, so they are amenable to using spot instances. So they've been using SkyPilot to save close to 6 times compared to on-demand. So because they are using CPU spot instances, the saving percentage is much higher than GPU spot instances.
So in the short time that you've worked with users, so have you noticed kind of like the expansion of number of users who are now more confident in terms of using the cloud? Because if you're not using cloud resources regularly, it can get intimidating for many users, right? Yes. So do you think SkyPilot somewhat lowers the barrier for entry? Yeah.
Absolutely. We are actually very excited about this aspect, perhaps equally or more so than cost saving aspects, right? We think this productivity aspect or lowering the barrier of entry is very important. The SOC example that we were just talking about, so these guys are biologists, right? They are trained in the natural sciences. They are not trained necessarily in computer science or in tech. What they told us was they actually shopped for other solutions, including solutions for batch jobs from the cloud providers. And they realized those interfaces were hard to use, hard to understand, right? Because they were designed for tech people. And they found SkyPilot to be much more approachable, very intuitive to use. And without it, they might not choose to use the cloud, right? They may just stay with their HPC cluster. So we are very excited about this aspect of lowering the barrier of entry, through a bunch of means that we talk about, automatically figuring out the best choice among a lot of choices, handling the cloud infra complexity, including managing spot instances and so forth. So we are very excited about that.
So you now have had several months interacting with users and also gathering feedback from the Skylab sponsors. So what's on your roadmap?
Yes. So we are hard at work in making this an open platform, making SkyPilot an open platform to make it easy for cloud providers to bring their cloud into this ecosystem of clouds, right? So that's one thing we are very focused on. We want to bring more clouds in, and we want to make it easy to do so.
And for our listeners, what clouds are right now supported by SkyPilot?
We currently support AWS, Azure, and Google, and we just finished integrating with Lambda Cloud from Lambda Labs that we mentioned is a low-cost GPU cloud. Our partners, our sponsor, IBM, they are actually adding support for IBM Cloud into SkyPilot. So now we have 4 hyperscaler cloud and the first specialized cloud, right? And I want to say, since our announcement in November, we've gotten a lot of interest from other cloud providers, or some focus on, let's say, greener energy, right? So going forward, we are very focused on making this a platform for people to bring their own clouds. Another thing on our roadmap is we want to make SkyPilot work on more environments, right? Right now we work on the cloud, right? But what if you have a Kubernetes cluster, either self-hosted or cloud-hosted? We want to look into running SkyPilot jobs with no change on your Kubernetes cluster. Or you may just say, I want to play with it. I have a local laptop only. Can I run SkyPilot jobs on my laptop? So that's something we are also excited about, bringing more environments to be supported.
And so the feedback you've gotten from, since you sit here in the Bay Area, from local tech people has been what?
I would say very promising. People are excited about this, but we are that focused, I should say, on supporting our existing users well, making them really successful. We have talked about a few examples where people are getting real benefits. Right? We want to gradually expand from that, but we are taking one step at a time.
So have you gotten to the point where you don't know every user?
I believe so. Yes, I believe so. The use cases we were talking about, because we knew them because these guys reached out to us, right?
Yeah.
We reached out to them, but we do have anonymized telemetry data suggesting there are many more users. We don't know who they are. We haven't gotten in contact. Maybe we'll talk to them on GitHub or on Slack later. But yes, I believe that is happening.
So for the listeners who might be thinking, okay, so everything that they've discussed sounds cool, and I know that Berkeley and Eon have a track record of pushing things forward, but how do I know if I jump in here that it just becomes another abandoned academic project?
Well, I think the give it a try and see what you think, right? See if it solves your real
No,
problem.
but is right now, are you beginning to, are you growing the community so that it's more broad than Berkeley?
Oh, absolutely, absolutely. We are seeing contributors from more than Berkeley, right? Quite a few other organizations. One company is heavily using, they are building on top of SkyPilot, so to speak. They're building the product on top of SkyPilot in using our programmatic API. And I think that is one piece of evidence where the community is forming. And we have spread to more than Berkeley, right? We have users from Stanford, from many universities, including Stanford, UC San Diego, and so forth. And the companies we were discussing, they were also heavily depending on this.
And for people who want to help or contribute or try SkyPilot, so what are some good pointers?
Yes, go to skypilot.co, which link to our GitHub repository, or you can Google us. And from the GitHub, everything we do is open source. From the GitHub repository, you can see our documentation, instructions to install, and all that stuff. We would love to also sit with you to listen to your problems and use cases. So feel free to shoot us a private message on Slack or email me. I would be very happy to sit with you.
I don't know if this is the case for SkyPilot, but usually the Berkeley labs have tutorials in the fall.
Yes.
Did one happen for SkyPilot in 2022?
It did. It happened in October 2022, and we actually put up all the materials on our GitHub as well. There are, I think, 5 or 6 Jupyter notebooks. You can scroll through or play with it, and that would be a great way to get a feel of the system.
And SkyPilot for an end user is, the surface area or the API is not that big, and it's not going to change that much. So a lot of the material that you put online from last year still helpful, right?
Absolutely. I think of it as a very self-contained, it's fully open source self-contained library you can install using pip install. Literally, you type pip install SkyPilot. You do not need to sign up anywhere else. It runs everything in your own cloud accounts, right? And the CLI we were talking about is very ergonomic, I should say. We have reasonable confidence. Behind the scenes, of course, we are evolving the backend and everything. But I think the CLI.
But for the end user, that CLI is going to be relatively stable, right?
It has been like that for more than a year, I should say. Like about a year ago, we were rolling out to our beta users. I don't think the CLI has changed at all.
All right. And with that, thank you.
Thank you, Ben. It's been great. Talk to you soon.